Hi and welcome back to a new video. Today we're going to look at the AMD 8700G, which was launched by AMD several days ago. When I saw the initial reviews, I thought that's an interesting looking CPU physically, because I saw that some of the components on the PCB that we see on AMD 7000 CPUs are missing. Then I thought that could be quite interesting, especially regarding delidding, maybe direct die, and also keeping in mind that the 8700G, which is again, I would say, typical misleading marketing name. That's something that has been done before by AMD, also by Intel, because you would assume that an 8000 series CPU is superior to a 7000 series CPU, which is not really the case, because this is much closer to an AMD Ryzen 7000 mobile CPU, which is probably also the reason why the CPU will not be soldered. Because the AMD Ryzen mobile CPUs are not physically prepared for the soldering process, they're skipping a few process parts, which is why it should feature normal conventional paste. And yeah, in today's video I want to find out, can we delete the CPU with our existing devices? Will it survive? And can we optimize the temperatures further? And also, how does the CPU look underneath? So that's the goal for today. Hetzner is a leading hosting provider and data center operator in Europe, operating hundreds of thousands of servers. Hetzner is especially known for their innovative server designs, which allow both a very high performance and affordable pricing at the same time. They run their own cutting-edge data centers in Nuremberg and Falkenstein, Germany, and in Helsinki, Finland. With their dedicated server AX52, which is based on Zen 4 architecture, you get the perfect all-rounder for a wide range of multi-threading intense workloads. And in case you have a smaller budget but still want a very powerful machine for less money, then I would advise to go and check out their server auction. There you can find affordable dedicated servers with reused hardware. Click on the link below to find out more about Hetzner. If we compare the 8700G to a CPU that is a bit more well known to us, the 7950X, you can see all those capacitors in the cutouts of the IHS, as I mentioned before, and all of these are missing on the 8700G. If we look underneath, you can still spot some of those caps. So there's definitely still stuff going on underneath the heat spreader. But before we proceed into the delidding process, I still first want to mount it in the system and get some comparison value numbers for the temperature. And I definitely want to find out if I have to do BIOS flashback to get it to work, or if it will just boot first with an older BIOS. In this video, I don't want to focus too much about performance and features of the CPU, because just check out some of the launch reviews if you want to see more information about that. Generally speaking, it is a G suffix CPU, like the 5700G previously. Those CPUs with G in the end just focus on having a very strong GPU inside. Nowadays, basically all the CPUs are APUs, like let's say a 7900X. But those have quite weak iGPUs, and that's basically the difference to this CPU versus other desktop CPUs on the market. And I just want to see if we can optimize the temperatures further. And I mean, I don't even know what the temperatures will look like under load, and those are just the things I want to observe. That's also the reason why I'm going to use the iGPU, which is probably the more common use case for this CPU. Otherwise, you would probably not get it instead of using a dedicated GPU. So I have HDMI connected on the left. For comparison, I'm going to run this 360 AIO, and also, as you can see, 00. So yeah, as expected, I will have to use a flashback to update to latest BIOS to make sure that it can actually run the CPU. Because on the default BIOS on the board, if you purchase it, it's probably too old, and you will have to use flashback to get it to a more recent to get the CPU to boot. This already looks much better. As expected, just BIOS update necessary. We will first look at the stock condition, so I didn't do anything else apart from loading the Expo profile in BIOS. Once we start Cinebench R23, we can quickly observe that there should be a power limit just below 90 watt on the CPU, at least that's what I assume. We see temperatures of about 80 degrees Celsius under load. The AIO is fixed with a pump speed of 2500 RPM, and the fans are running at 1200 RPM. And we can see a score of about 16,500 points running stock. I'm just rerunning again to show you the clock under load, and it seems to be fluctuating between 4625 MHz up to 4750 MHz roughly. Those are the clocks stock condition R23 under load. In the second test, I want to try how the CPU behaves with PBO enabled. So I'm just going to enable this to enhance the power limits and see how the CPU behaves now. Now running R23 again, we can see that the CPU package power definitely increased. Previously it was a max of like 87, now it's 106, so it's almost 20 watt improvement, and also the clocks improved by, I would say, about 125 to maybe 150 megahertz. Just running again to show you the temperatures, which you can see are definitely in the higher range right now. 93 degrees Celsius on this core, which is definitely affecting the performance, because starting from 85 degrees Celsius, this CPU is going to lower the clocks under load. But we can see a slight improvement from about 16,500 to 16,900 points. Now we are also going to do a classic all-core fixed overclocking. For that we go to CPU core ratio. And here we set the core VID to 1.29 and the CCX ratio to 50, which means a core fixed clock of 5 GHz. Now the CPU clock is fixed 5 GHz, 1.29 VID, which also results in quite solid temperatures. We can see almost 93 degrees Celsius. Keeping in mind that the CPU will start to throttle from 95, this is pretty much on the limit. And with this manual overclock, we can get to about 17,900 points. With this setting, we are pretty much on the limit, and we are still about 5% behind a 7700X, which scores about 19,000 points in R23. But at least with this setup, you can get somewhat close in CPU performance while also having a very strong iGPU. There are also clock limits when it comes to temperatures, even in stock condition. Once you exceed 85 degrees Celsius, the CPU will no longer be able to maintain a max clock of 5150 MHz, but rather 5050. And once you exceed 90 or 95 degrees Celsius, it will be even lower. So there's definitely going to be a benefit keeping the CPU as cold as possible. And also, maybe if we can lower the CPU temperature due to delidding, we will also be able to clock it higher with a manual overclock. Time for the delidding process, and we will just do it the same way as with a Ryzen 7000 CPU, going to use our Ryzen 7000 delidder. The question is going to be if there is sufficient clearance underneath the IHS to move it back and forth sufficiently. We can still see some of the caps underneath, but yeah, it's only one way to find out. In the first step, I will just move the IHS to one direction first and see if it's going to break anything. So first step looks kind of alright. I don't see any damages. I will just put it back into the litter, move it back and forth until it's loose. Shouldn't be like with Ryzen 7000, you have to move it like 50 times. Here it's maybe twice because it's not soldered. I just pushed it in the opposite direction and I can already see that the IHS became loose. As expected, the IHS looks a bit different. We have some kind of elevation in the center and also a thermal paste on there. The CPU appears to be undamaged, cannot spot anything. Seems like the Ryzen 7000 delidder is fully compatible. There are like no damages on any of the caps. We also have, as expected, only a single chip in the center. There is no I/O die and like single CCDs as what you have with Ryzen 7000. It's just one chip, very similar to the Ryzen mobile CPUs. Now as a simple and direct comparison between the two CPUs, the Ryzen 7000 on the bottom and the 8700G on top. There are a few things I noticed. I think at least subjectively, the die on the 8700G seems to be lower than on the Ryzen 7000, which also would make sense because the mobile CPUs are typically a little bit lower when it comes to just the silicon height. Also, if we compare the IHS, obviously we have the gold plating inside the Ryzen 7000, which is the preparation for the soldering process. Soldering process also means that we have about 0.5 millimeter of indium or like 0.4 millimeter. Whereas here, because of the conventional thermal paste used, we have this elevation in the center that compensates both lacking of indium solder and also probably the lower die height. That also means we have this. This is like a new version of the Ryzen 7000 direct die frame, and this is going to be one that's compatible also with X3D CPUs. It's already in production, and I don't think it's going to be working with this. Like direct die is probably going to be quite difficult because I think of the die height, but that's something we will have to measure. And to do all the measurement, see the die height and everything, we're going to use this Keyence 3D profiler, which is also a device I'm very happy to have, but also one I didn't show yet. CPU is now going to be fully measured with optical measuring methods. It's very, very interesting to see. And just like that, we have the CPU full as a 3D model in here. And we can also do tricks like stretching the height, which then gives you a nice perspective. For example, if you want to figure out if the die is bent, which you can see slightly by overstretching the height. That was 1800%, but that's also not the intention right now. I mainly want to do measurements to see the die height. And now we want to check the height difference between this surface right here, the chip, and the surface of the PCB. I can simply select this surface and then just also make it a little bit smaller to go away from the edge. And same thing for the outer surface. Now I can simply hover my mouse over the area to see height measured on the bottom. We see the max in the center and the min on the right of the PCB. And if I now hover my mouse over the chip, I can see the height measured between the PCB and the die. So we have minimum height of the die of about 0.45 millimeter. And if I go all the way to the center, it's about 0.49. So it's somewhere between 0.45 and 0.5 millimeter on die height. With this information, we know that existing direct die products would not be compatible with the 8700G, simply because the Ryzen 7000 CPUs, they have a die height of about 0.8 millimeter, which is almost twice as much. And like the direct die frame would not be compatible, same as like the micro direct die water cooler. And I don't really see a market for this as well. That's why I wouldn't probably make products for the 8700G. I mean, you can let me know if you would be interested in seeing that, but just personally, I don't see why you would really do that on an 8700G. What I think would be quite interesting though is the normal delidding and swapping from conventional paste to liquid metal. And to be able to do that, we would have to measure, and that's what we're going to do, to see the IHS, if it has enough clearance to make up for potentially less layer of thermal paste in between. So we will have to remove the glue on the IHS and then just check the distance between the spot where it makes contact to the PCB to the center, which is slightly elevated, to see if this would make direct contact with the die or not. And so we have the heat spreader right here. Surface area looks pretty even, that's good. And now I put a line to cut basically through the profile of the IHS in this line right here. And here we can see the profile. So for example, this part right here would be that one. This is the entire contact area. And again, the one on the left would be this part right here. And now the goal would be to check the height difference between this, which is the center, to this, which is the outer part that will make contact to the PCB. And this has to be less than 0.45 in order to make perfect contact once we just want to reapply liquid metal. To measure, we take a line-to-line comparison, which is basically catching the line itself. So even if it's not perfectly aligned, it will do it itself. And we can see that between this line right here and this one, we have a height difference of about 0.18 millimeter, which is more than sufficient. It's a lot less than I expected, so there will be no modifications needed to the IHS. First, I want to try the KryoSheet to see what kind of temperatures we can get. It results in really good temperatures on GPUs, but on CPUs sometimes not as much, simply because the energy or the power density on CPUs is so much higher than on GPUs. The graphene pad is slightly electrically conductive, which is why I decided to quickly protect the surrounding components. In addition, I don't have to cut the pad to shape because it doesn't really matter if it's extending over the die. And now I will have to place carefully the IHS, close the lid, and we should be good to go. Now, as usual, the interesting part is going to be the first post. This is looking very promising, and also the good thing about this type of modification is that we can basically use any kind of cooler because the stock height is still going to be the same. So you can use this modification with any air cooler, AIO, whatever water cooler. It should be no problem because we still use the original IHS. Post was no problem, also loading the memory profile was no problem. Idle temperatures look good, and now I want to see the temperature under load. First look, this is really decent. Same CPU package power like 87. But it seems to be a bit colder, while clocks look like the same. But I think I will definitely have to look into the chart. But first look, this looks good. And also the score is pretty similar to what we had stock, like 100 points difference, but that's just fluctuation. In the stock condition, which you can see in the blue line, we have about 75 degrees Celsius under load. Now delidded with KryoSheet, we can decrease the temperature by about 10 to 11 degrees Celsius. That is already a good benefit. The next comparison with PBO Active. CPU package power is again at just below 110 watt. Temperatures seem to be going in the direction of about 80 degrees Celsius. Precision Boost Overdrive definitely changes how the CPU behaves, which you can see in the behavior of the temperature. Due to PBO, we see a general increase in temperature by about 10 degrees Celsius over stock, thus about 85 degrees Celsius under load. Now with KryoSheet and the red line, we can decrease the temperature to about 70 to 73 degrees Celsius. So that's again an improvement of about 10 degrees Celsius. With the static overclock, it's again same condition, 5 GHz, 1.29 VID, and you can see the package power draw is also the same, but we can definitely see a much lower core temperature. Score is about the same again, it's about 100 points difference, which is the normal fluctuation. With the manual overclock to 5 GHz, the temperature is much more stable, simply because we lock both the voltage and the clock. And we see about 85 degrees Celsius under load, and with KryoSheet about 70 degrees Celsius under load. While the KryoSheet results were a bit better than I expected actually, I still want to move over to liquid metal and try to see how much we can squeeze out of the CPU. At this point you might ask yourself the question, why are we even doing that on an 8700G? And to a certain degree, I don't even know myself. I just like playing around with these things and like to see what you can optimize. On the other hand though, those CPUs, same as the previous APUs, are often used in tiny systems, which means that you are limited to what kind of cooler you can use. And if you're able to lower the CPU temperature drastically with like Delidding, then it might allow you to run the system like with a smaller cooler or with a slower fan speed, thus have a lower noise level. So there are definitely reasons why people are doing this, even though I would probably not use this CPU myself, as I like to play around with it. And before I forget about it, obviously the reason why you would try to go with such a product instead of liquid metal is the no maintenance factor. Because with liquid metal, even though it's a nickel-plated IHS, there is still the risk of something going wrong or that you would have to delete again and reapply liquid metal. That is a factor you would not run into with those graphene sheets. The contact and pressure was definitely very good. Also, one thing I want to highlight, I'm not sure why people still think this or always think this, those pads are not reusable and they should not be reused, because if you use it again, well, first of all, if you remove it, they often tear apart. And also because of the compression in the center, you will not be able to get the same kind of temperatures again on a second mount. Liquid metal is applied, you can see I spilled a little bit here and there, but it's just on the Kapton tape, thus won't matter, so we'll just leave it on there. We'll put the IHS back, put everything back into the socket, and then let's check the temperatures. In idle, this already looks a tiny bit better. Same power draw, 87 watt, and we have just around 60 degrees Celsius, 55 to 60. That's very solid. And also score still the same. Conductor Node Extreme further improves the CPU temperatures, even over the KryoSheet, and by a lot. Even without any modifications like PBO or overclocking, we can see an improvement of about 15 to 20 degrees Celsius. Continuing with PBO Active, power consumption in line, again like 100 to 110 watt. Temperatures around 70 degrees Celsius. In the PBO scenario, again, we can see a good improvement with the liquid metal over the KryoSheet, but it's also much more difficult to draw a good conclusion of the actual temperature improvement, because we see those big fluctuations in clock and voltage and thus also temperature. Now with the static overclock again, 5G 1.29 volt, which was previously the max, especially temperature wise. Now I want to see if the temperatures are lower and if we can get more headroom for maybe a higher overclock. The CPU power consumption is slightly lower, which is definitely caused by the lower CPU core temperature. We're not even hitting 70 degrees Celsius. Previously it was like 92, but you can see clocks and voltages are there. And also the score, crazy. So we should have a lot more headroom. As expected, with the manual high overclocking and after delidding with liquid metal, we can see the biggest improvement. We go down from about 85 degrees Celsius to just above 60 degrees Celsius. Overall, about 20 to 25 degrees Celsius possible improvement. That is extremely nice. It took me a bit to figure out the sweet spot, and it seems to be 5.3 GHz all core, 1.37 volt, maybe that's rather high for this type of CPU, but I can tell you that the temperatures should be fine. The temperatures at the beginning of the benchmarks are in the lower 70s. At the end of the benchmark, they're going to be in the higher 70s, closer to 80 degrees Celsius. Power consumption, 110 watts. You can see 5.3 GHz stable. That's crazy. That's a crazy improvement. 18,800 points. And one thing to keep in mind, because Hardware Info is always stealing some of the performance while I'm doing this, you can see it's like 3, 4, 5%. Yeah, performance in the background. So I'm just going to close Hardware Info and rerun it again. And there we have it, 20,000 points. Overall, I have to say that playing around with the 8700G was actually a lot of fun, simply because the delidding process was simple and easy. And with this, I was able to get a big change in temperature, like 20 to 25 degrees Celsius lower temp, which then allowed to further increase the voltage and also clock by 300 megahertz, which then ultimately allowed me to increase the performance of about 15 to 17%, which is definitely a lot, and allows to get the same kind of performance as what you would have with a 7700X, which has more benefits when it comes to like cache and everything. So it's not so easy to get this kind of performance with an 8700G, but with these modifications, it was possible. And that's actually quite cool, especially because the CPU is not locked like an 7800X 3D. So that was quite a lot of fun for me to try. I hope you also enjoyed it. I'm still not sure if there is a real use case for the CPU, but it's something I just had fun playing around with. Thanks for tuning in. See you next time. Bye bye.